Hi guys, good afternoon. So in the last session, we went with the DTP and BTP protocol. Now today we'll start with the STP, okay, which is spanning tree protocol. Spanning tree protocol. So what is this spanning tree protocol? This is a protocol which is used to avoid layer 2 loops, okay. So you can see it's used to avoid loops at layer 2, okay. Now how it is going to avoid the loop? Before that, we need to understand how the loops will be created, okay. So let me directly go into the lab. Security precaution, the user has been logged because there were so many log on password change account. Okay. So we'll take few switches and I'll connect them. Consider this scenario. So these are switches, and let me change the name so that there will not be any confusion. S1, S2, S3. Now what will happen? See, if there is any broadcast, okay, if there is a broadcast on, switch on. So what is switch on will do? Single broadcast domain by default. So we'll forward it this side as well as this side, right? This is what your switch one is going to do. Now, right now, first of all, let's consider the message which is coming on this side. Okay. So this side, let me change the color. Okay. Now, first of all, I'll consider the message which is going to the switch 2, right? So what your switch 2 will do? Switch 2 will receive a broadcast message on the interface F0 by 2. What a switch does with the broadcast? Broadcast it. Forward it this side, right? Then what it is going to do? Switch 3 received on F0 by 1, right? Switch 1 will receive on F0 by 1, right? This will keep on going. Loop is there. And if we consider the second message, switch 3 will receive it, then it will forward it to Switch 2 will forward it via interface F0 by 2. Again, it will come here, again here, again here, again here. How many loops are there? 2 loops are there. One in clockwise direction, another one in anti-clockwise direction. 2 loops will be there. And right now I have connected only 3 switches. And every time this traffic will keep on increasing. So what will happen? The condition that will arise here, that condition will be known as your broadcast term. There will be a condition which is known as, and this broadcast term will bring down your network. So we want to avoid it. And for this reason, the STP protocol is there to avoid it. Okay. So what your STP will do, STP will block the link. One of the link your STP is going to block. So here you can see like all these are green, but only one link is there, which is orange, right? Why? Because this link is blocked due to STP. STP is by default implemented. We are not implementing it. It is by default. Same like DTP, VTP. This is also by default there. Clear? Okay. Now, if your STP will block the link, what will happen? This will be a kind of situation that this link is not present. This kind of situation it will be. And if it is this kind of situation, in that case, now if there is a broadcast, it will come this side as well as this side, but it cannot come on this side. Why? Because this link is blocked. So you cannot use this link. And if there is, the message will not travel on the other side from switch 2 to switch 3 and from switch 3 to switch 2, there will be no loops at all. Clear? Okay. This is clear. But how your STP will make a decision that, okay, which link to block? How your STP will make a decision that which link it has to block. So in STP, these switches, they will communicate with each other. And for communication, they will be using a message. That message will be known as BPDU. Okay. What is BPDU? BPDU stands for Bridge Protocol Data Unit. This is the message. And in the BPDU message, they have information about bridge ID. What is the bridge ID? Bridge ID is a combination of your priority and MAC address. This is a combination of your priority plus MAC address. This is clear? Okay. So there is a default priority assigned to all the switches. In case of STP, there is a default priority that is assigned to all the switches. Okay. So what is this default priority? The default priority value is 32768. And this is the default priority. This is clear. And now, these switches, let's consider they have the MAC addresses M1. And this guy here is having M2. And this guy is having M3. Okay. So now what your STP is going to do, STP is going to make certain elections. There will be certain elections. So what are the elections that will be there? The first election. Okay. And before that, let me also tell you about STP host. So there is something called as STP host. Okay. Each interface is assigned with a host. So if your interface is 100 Mbps, that means fast Ethernet. The host will be 90. If your link is 1 Gbps, gigabit link, it will be 4. If it is 10 Gbps, it will be 2. So right now these links you can see fast Ethernet. So that means the cost will be 19. Here also the cost will be 19, and here also the cost will be. This is clear. Okay. Now let's go with the election. The first election that will be there. Okay. The first election will be what? Your root bridge election. Okay, these switches, they will communicate with each other and they will select one of the switch as root bridge. Okay, how they will select the root bridge? So in case of root bridge, first priority will be given to least priority. The switch which is having the least priority will become the root bridge. And if priority is equal, which in by default case it will be, in that case, it will check the least MAC address. Okay. Now, based on this, which switch will be the root bridge? Yeah, least MAC address. Priority is equal, so least MAC address M1. So that means this switch will become what? Root bridge. So if this is becoming root bridge, these will become non-root bridge. Okay. This will also become non-root bridge. This is clear? Yeah, automatic. We don't do anything in it. Entire STP protocol is automatic. Okay. Now, second election. Once the root bridge is elected, second election is root port election. So how the root ports are elected? First of all, these root ports, these are found only on non-root bridge switches. They will be available only on your non-root bridge switches. And how your non-root bridge switches will find it? These are least code path to the root bridge. They will find the least port. Okay. And your root ports, they will always be in forwarding state. They will always be in the forwarding state. Okay. So now what will happen? M2, I mean S2 and S3, they will find out the root port, that which port will be the root port. So how they will find it? It will be the least cost path to the root bridge. So like switch 2 is what? It is a non-root bridge. It will try to find out a root port. So how it will find out? It will check that, okay, if I'm going via F0/2 interface, what is my total cost to the root bridge? 19. And if I'm using F0/1 interface, it will be 19 plus 19, 38, right? So through which interface I'm having the least cost? F0/2. So that means this interface or this port will be my root port. Okay. So here, this port will be elected as what? Root port. Okay. Same way, switch 3 will find out which port will become root port. F0/1 or F0/2? F0/2, same port. Now this is your root port election. Done. Next is what? Next election is about your designated port election. Okay. Designated port election. So how designated port will be elected? First of all, these are found on root bridge and non-root bridge, all the switches. Then ports that are directly connected, or I can say ports directly connected to root port are designated ports. The ports which are directly connected to the root port, which that are designated port. Another way you can say this thing is all ports of root bridge are designated port. Say it like this. All the ports of your root bridge are what? Designated port. And even your designated ports, they are always in forwarding state. Okay. And also one more thing, that each link will have a designated port. Okay. And these ports are always in forwarding state. This is clear. So looking at this thing, I can easily say that these two ports, these are what? Designated ports. Okay. So this is my designated port. And also this port is my designated. So ports which are directly connected to root port. So this is directly connected. This is also directly connected. They are the designated port. All the ports of root bridge are designated ports. This is my root bridge. All the ports are designated ports. But again, I'm saying that each link will have a designated port. So there is a designated port available on this link. There is a designated port available on this link. Is there a designated port here? No. So here also we have to calculate a designated port. So how we will find out? So first of all, least cost will be checked. When S2 will say that, okay, if I'm going via this path, my total cost to the root bridge is 38. Okay. Switch 3 will say that, okay, when I'm going via this path, my cost is both are equal, tied. So that means cost cannot decide now. Next thing they will check is what? They will check the bridge ID. Okay. So bridge ID is what? Priority and MAC address. They will say, switch 2 will say my priority is this. Switch 3 will say my priority is this. Priority also not working. Next is what? Switch 2 will say my MAC address is this. Switch 3 will say who has the lower. So that means switch 2 port will become designated port. Okay. So here this port will become what? Designated port. Clear? This is how designated port election will be. Then after last election, alternating port election. All ports other than root port and designated port are alternating port. All the ports other than your root port and designated port are alternating port, and your alternating ports always in blocking state. These are the ports which will be blocked. So that means in our topology, we can see that, okay, designated root and all those selection is there. Only one port is remaining. And this is the port which will be alternating port, which will be blocked. So here you can see this port is blocked. This is clear. how the STP will make the blocking decision. Yes, all the ports which are not the root ports, not the designated ports, they will be alternating. So only this port was remaining, which was neither a designated nor a root port. So that's why this port is what? Alternating. And it will always be in the blocking. This is clear? Okay. Now, if we talk about states, I was talking blocking state, forwarding state. So your ports are going through several states. Whenever you connect a port, the port will go through several states. So what are those states? CP port state. So first state is disabled. Second state is blocking. Third state is listening. Fourth state is learning. Fifth state is forward. So when your port is disabled, that means that time your STP cannot allow BPDU through the port. When your port itself is disabled, there will be no BPDU passing through the port, which will not learn the MAC addresses also because no communication at all. So there will be no MAC learning, okay, as well as no data forwarding. Nothing will be there. Then you bring up the port, you connect the device. First of all, it will go to the blocking state. In the blocking state, it will just allow BPDUs. It will just send the BPDU through the interface and nothing else. So there will be BPDU, but there will be no MAC learning and no data forwarding. It will not forward any data frames through that particular port. When the port moves to the listening state, now the port has started listening to others' BPDU. So again, here also BPDUs will be exchanged, but there will be no MAC learning and no data forwarding. Okay. Learning. So here MAC learning will start, which will start learning about MAC addresses and which will also start learning about who is the root bridge and all. Okay. So BPDUs will be exchanged. MAC learning will be there, but still there will be no data forwarding. And if there is no loop, the final state will be what? Forwarding, where switch will forward. BPDU messages also, MAC learning will also be there, and data forwarding will also be there. These are the states through which a port will pass. Is that clear? So when I say forwarding state, that means it will pass through all these states, then it will come to the forwarding state. When I say blocking state, that means once the root bridge and all the elections is done, root port designated port, then after it will block this port. Okay, so two permanent states are there, blocking and forwarding. And these are not permanent states. Okay. Your listening, learning, these are not permanent states. Is that clear? Okay. Now the thing is, how much time does it take for a port to come up? Right? When you bring up a port, how much time does it take for the port to come up? These are the elections done. So if we talk about the time that it takes for the port to come up, here. Okay, so how much time does it take for the port to come up? Let's talk about it. So your switch port, see what are the states we have? I'm taken the state. Okay. So first is disabled. So when STP is disabled, your port is disabled. It is permanent state, so can do anything. It will remain there. Then your blocking state. So in the blocking state, by default, it will spend how much time? 20 seconds. Then we have listening state. In the listening state, it will spend 15 seconds. Okay. Then we have learning state. In the learning state, it will spend 15 seconds. And fifth is forwarding state, which is again a final state. So here it will remain permanent. Okay. So total time that a port takes to come up in case of STP is by default how much? 50 seconds. It takes 50 seconds for a port to come up. Is that clear? Now, how it is decided that how much time it will take, like this. So there are certain timers in the STP. In the STP protocol, there are certain timers. So what are these timers? Let's talk about them. STP timers. So first is hello timer. What is hello timer? How frequently the BPDU messages will be sent. Okay. So by default, this is 2 seconds. The default value for hello time is what? 2 seconds. That means every 2 seconds, switches will send what? BPDU messages to each other. Then we have forward delay timer. What is forward delay timer? How long a switch port will spend in listening and learning state. That how much time it will spend in the listening as well as learning state. That time is known as what? Your forward delay time. Okay, how much it is? By default, 15 seconds. That's why in the listening also 15, in the learning also 15. Then third we have max age timer. Okay, so what is the max age? How long a switch port? See, the switches, they will send BPDU message every 2 seconds. So that means my neighbor should also send me BPDU message every 2 seconds. I'm supposed to receive a BPDU every 2 seconds. But if I'm not receiving, then how long I will wait before I will declare that my neighbor is not there? Okay. So this is the time duration, that how long it is going to wait if a BPDU is not received from the neighbor. So how long a switch port will wait if a BPDU is not received from the neighbor? Okay, and the default value for this is 20 seconds. These are the timers. Okay. This is clear? Okay. So system, port state system, timer, how much time? Okay. Now in STP, we have a feature. What is the feature? First of all, understand the thing. that, see, like say these are the switches, and here if I connect a PC, now STP is used to avoid layer 2 loop, right? So if I connect a PC here, is there any possibility of loop on this link? No possibility. But still my STP will check. See, my port is still in the down state, right? It is going through the listening, learning, all those states. And finally, when STP will be sure that there is no loop, then it will come to the forwarding state. But right now, if you see, I'm sure that, okay, this is a single link and my PC will never generate a loop. Then why should I wait for 50 seconds? Why should I wait for 50 seconds? So see here, now it is what? In the forwarding state. So why should I wait that long? Okay. Why should I wait this long also? So what I'll do, I will enable a feature of the STP, which is known as STP port fast. What is the STP port fast is going to do? It will immediately move my port into the forwarding state. Rather than going from blocking, listening, learning, directly my port will go to the forwarding state. Okay. All right. So right now you saw that when I connected it, okay, when I'm connecting it right now, the port F0 by 3, it will take that much amount of time. Now what I'll do, I'll go and configure here port fast. Okay. I'll go to the switch, CLI, enable, configuration terminal, interface F0 by 3. This is the interface where I want to configure. Oh, sorry, F0 by 3. And I'll say spanning tree port fast. Done. Once I will say this, now if I will connect the cable directly to the forwarding state, now it's not orange anymore. Why? Because I have configured this port as a port fast. That means immediately it will go to the forwarding state, right? Okay. On the all the end host, wherever you connect end host, those ports you will configure as a port fast. Okay. If port path is configured on an interface, it will directly move to the forwarding state. Okay. It will not wait for blocking, listening, learning. How do you configure it? Just go to the interface. Interface name, and you'll say spanning tree port path. This is how you're going to configure. This is clear. Okay. Now you're configuring port path. That means basically kind of you can say you are disabling STP. Kind of you're saying that you are disabling STP because STP will not check for loops on that particular port. But sometimes what can happen that, in your company, employees can try to be very smart. How? Now, let's say this employee here, he is thinking that, okay, what I want to do is I want to use my personal laptop also here. Okay. Now, if he want to use personal laptop, he needs one more cable, but he is getting only one cable from here. So he will say that, okay, what I'll do is I'll go and bring an extra switch from my home. I'll bring an extra switch, and this extra switch I'll connect here in this, and then I can connect like this, right? And if he is over smart, then he might connect two links from here so that get better speed. But even if he is not connecting, let's say he is connecting only one cable, this is the switch which is not from your organization. It is an unauthorized switch. That means an unauthorized device is connecting to your network, first thing. Second thing, that if this switch by any chances, it has less priority or less MAC address. what will happen? Root bridge will change. If your root bridge will change, your root ports will change. Root ports change, designated ports change, your blocking ports also change. That means your entire STP topology changed. This is something we don't want in the organization. And why all this will happen? Because this guy will send a BPDU message. This switch will send a BPDU message and that will change your entire topology. Okay. So we don't want that kind of scenario. So on the port fast interfaces, the interfaces where we will configure port fast, you need to filter these BPDU messages. And for this reason, you will use a concept which is known as BPDU guard. Okay. You will use what? BPDU guard. BPDU guard. What is the BPDU guard? Okay. What is BPDU guard? If a port fast interface is configured with BPDU guard, the BPDU guard will monitor incoming BPDU messages. It will continuously monitor incoming BPDU messages. And if a BPDU is received on the interface, it will shut down the port and move it to error disabled state. The port will be moved to error disabled state. So in error disabled state, what happens? Even if you manually go and give no shutdown command also, your port will not come up. So that means if this guy is trying to be smart, okay. So what will happen? You configure BPDU guard here. The port will immediately go to the down state. Okay. The F0/3 port will immediately go to down state. And if this guy now he will connect legitimate PC also, no communication. And in your switch, a log will be generated that, okay, on this port, BPDU guard was configured and a BPDU was received. So that means, see, if this guy wants to work, he has to work first of all. So he has to raise a complaint that, okay, he is not getting a connection. As soon as he will raise a complaint, you will go to the switch and check. In the switch, you will find a log that a BPDU was received. So you will automatically come to know what happened, right? So how do you configure it? Interface F0/3. Sorry. You will go to the interface and you will say spanning tree BPDU guard enable. Okay, and now you will see in some time this port will automatically move to the error disable state, and here in this switch you will find a log also. Yes, no one can connect any extra switches in your network. Okay, so as soon as, see here, this port is down, you got a log that spanning tree block BPDU guard, receive BPDU on the port F0/3 with BPDU guard enabled, and it is disabling the port. Okay, and also it will give you BPDU guard error detected, putting the port in error disable state. Okay, and this way this port will go to the down state. Now if this guy, okay, he will think that, okay, now he don't have any connection. So what he will do, he will connect the legitimate cable back, and then he will try to be smart again, and he will say that, okay, I'm not getting a connection. He will try to raise a complaint because now he will not have communication. And then you will go to the switch and you will see all these things. And you'll come to know what happened. Okay, so this way you can track also that what the people are doing in your company, right? Now, if you go and give, see, right now my port is in the down state. You can see here, my interface changed state to administratively down. So even if I go to this port interface F0/3, and if I say no shutdown, my port will not come up. See here, it will still say change state to down only, not up. So what you have to do, first of all, you have to manually shut down the port. Then you have to bring it up. Then your port will come up. If your port is in error disabled state, first of all, manually shut down the port, then bring it up, and your port will be up again. Is that clear? How BPDU guard works? Okay. So how do you configure it? And here, if the port is in error disabled state, you have to manually shut down the port. And bring it up using no shutdown. Otherwise, the port will not come out. Okay. And how do you configure the BPDU guard? You just go to the interface. The interface name. And then here you will say panel tree BPDU guard init. That's clear. Error disabled state only comes in the directory. BPDU must be received. This error disabled state you will see in two concepts. One is this right now, BPDU guard. Another time you will see when we discuss about port security. In these two concepts, you will see the error disabled state. Okay. This is clear. So with BPDU guard, what is the thing that first of all, if somebody is making this kind of mistake, then what will happen? Your port will go to the down state. And if somebody is making again and again, or you're working in a large organization and so many people are trying to be smart, there are so many errors you will get. All the ports will be down and you have to manually go and shut down and no shut down the port, right? So in place of this, what do you do? Better than your BPDU guard, there is another concept, BPDU filter. So BPDU filter will not put your port in the down state. It will not shut down the port, but also it will not allow the communication. So that if they will connect legitimate PC, they will have communication. If they connect a switch, no communication, like this. Okay. So BPDU filter. This is another concept. Now, what is the BPDU filter? Same kind of theory is there. But if our port pass interface is configured with BPDU filter, it will block incoming as well as outgoing BPDU, both the BPDU. Your BPDU filter, your BPDU guard will only monitor incoming BPDUs, but BPDU filter will filter both of them, incoming also, outgoing also. Because see, if you are sending BPDU message, in the BPDU message you have priority, you have MAC address, you have information about your root bridge. So you don't want to share this kind of information. Okay, this is the first thing. Another reason, you don't want that, okay, any root bridge election should be there, extra root bridge election. So both the incoming as well as outgoing BPDUs are filtered. Okay. And if a BPDU is received on the interface, the port will not go to downstate because it is already blocking the BPDUs. So port will not go to the downstate, but it will remove the port pass feature from the interface. Okay. BPDU filter will remove the port path. So that next time when somebody tries to connect, again 50 seconds it will take. Communication, if PC is there. Yeah. If PC is there, communication will be there. But if switch is there, no communication. Okay. And how do you enable the BPDU filter? Interface. Just in place of BPDU guard, use a BPDU filter. And this command is not supported in packet tree. Here you will say spanning tree, BPDU filter, enable. Clear? This is clear. Now, these things we are worried because, sometimes what will happen? Somebody will connect a switch, which will have less priority, less MAC address, and your root bridge will change. So why not prevent accidental changes of the root bridge itself? Okay, so for this reason, we have one more concept, which is known as root guard. Okay, this is known as root guard. What is root guard? It is used to prevent accidental changes of the root. That by mistake you connected a switch or somebody else connected, your root bridge should not change. And you will configure the root guard on the root bridge. Okay, how do you configure it? Interface name, and I'll say spanning tree guard. Okay. This is how you can configure root guard. So let's say, for example, here in this topology, this is my root bridge. So any BPDU can come from F0/1 and F0/2 interfaces. So I will say on both the interfaces, I want to guard my root bridge. So what I'll do, I'll just go here. Interface range F0/1 and 2. Spanning tree guard. This is how you enable the root guard. Clear? Now, switches. Yes. Switch to switch connectivity interface. There you configure the root guard. Okay. All right. Now let's see how you check the STP informations. So if I click here, let's say this is S2 switch, and if I check here,
Sir,
yes, hi.
how we gonna do STP on the switches?
How?
Matlab, uh, if we need to apply any this root guard or anything,
I just
then hello?
here. I just applied here. This
No,
is
no. I'm telling about the spanning tree protocol.
this is by default implemented.
Okay, if the loop is generated, then STP is automatically generated.
Before STP, okay, before loop also your STP is already there. You see here this link is blocked automatically. Why? STP is already running. STP will not wait for the loop to get created. It is already there. Okay.
Okay.
Yeah. Okay. So we are not implementing it. It is by default already implemented in the switch.
Okay.
Yeah. So now if I want to check the STP information, I just go to the switch and I think I enabled root guard in wrong switch. No, great. You give the command to spanning tree. Okay. So now see here. You see here two information, right? This is about VLAN 1 because by default only one VLAN is there. Okay. If you see here, by default, one VLAN is there. Okay. In this VLAN, we get two information, root ID and bridge ID. So what is the root ID? It is the information of your root bridge. And bridge ID is the information about the self. So right now I'm checking on S2. So this is the S2 information and this is the information of root bridge. So every switch will have information about root bridge. Okay. So you can see about the root bridge. This is the priority of the root bridge, 32769. Now you'll say I said 32768. If you see here, when I said about the priority, I said what? 32768. And here it is saying something else. It's saying 32769. So how it is? It is because 32768 is the priority and it is adding the VLAN number. So VLAN 1. So 32768 plus 1. 32769. If it is VLAN 2, it will be 32770. So your actual priority is 32768 only, but it is also showing you the VLAN number. Yeah, automatically. We are not doing anything. Okay. Then this is the MAC address of the root bridge. This is the host to the root bridge. So right now I'm checking on S2. This is my S2. And on S2, my host to the root bridge is 19. Through which interface? F0 by 2. You can see through the F0 by 2. Right? And according to our calculation, your F0 by 1 should be designated port, F0 by 2 should be root port. You can see here F0 by 1 designated, F0 by 2 root port. And this side F0 by 3 PC is connected, so that will be designated port. And all your root port and designated port, they will be in the forwarding state. Then you can see here hello time 2 seconds, access time 20 seconds, forward delay time 15 seconds. So this is the information available on S2. If you check the same information on S1, which is itself the root bridge, how the information will look like. Let me go and check on S1. This is S1. You can verify here. Show spanning tree. Now this is the same. Root ID and bridge ID, all the information will be same. You can check the MAC addresses. Right? And it says what? This bridge is the root. And according to our calculation, both the ports were designated port. You can see both the ports are designated port and forwarding state. This is clear. Okay. Same thing here. I will check here. One port will be root port. Another port will be alternating port. Okay. So that also we can check here on the S3. This is the S3. So spanning tree. So you can see F0 by 1 will be alternating port. F0 by 2 will be root port. Alternating port, blocking state, root port, forwarding state. On which port root bridge is connected? F0 by 2. Coast is 19. This is how your STPs work. Okay, and it says STP spanning tree enabled protocol is IEEE. Okay, so what is IEEE? Let's talk about the different protocols. That's what does it mean? So if we talk about the protocols, So these protocols we can divide in two categories. Okay, open standard and Cisco's own protocol. So first, let's talk about open standard.
If it is 4 or 2, that will also show that.
Yes, if you are using gigabit Ethernet or fast Ethernet.
X2 should be a root, right?
Hmm?
Root bit should be X2, right?
Why?
MAC address is less.
You want to see in the real scenario, right? Hmm?
Yes.
That's one. This is S1. MAC address is 0009. Bridge ID is what? Your priority and MAC address only, right? So your MAC address 0009 here. Here 000B. Who is bigger, 9 or B? 9 is bigger. How? B means what? In hexadecimal. Right? After 9, then 10 and 11. B means what? 11. So smaller is who? Root bridge only. Here you check in the S3. E0. And in case of root bridge, it is 0 only. Got it? Okay. So now let's talk about the protocols. Packet tracer has problems, but not that kind of problems. We'll select anything random. First of all, let's talk about open standard protocols. Okay. So in open standard, the first protocol is your STP, spanning tree protocol, also known as STP. So this STP protocol, first of all, the IEEE code, because it is open standard, 802.1D. This is the IEEE code for this. And D dot, that is 802.1Q is for the .1Q protocol. That is different. Okay. Like 802.11 is what? Your wireless security. Your Wi-Fi is what? 802.11. Okay. So 802.1D, this is your STP protocol. Okay. And this protocol, it takes 50 seconds of time. We have seen listening, learning, forwarding, right? So it takes 50 seconds of time. And in this, only one STP for all the VLANs. That means doesn't matter you have 10 VLANs, 20 VLANs, 100 VLANs. For all VLANs, only one root bridge will be there. If there is only one root bridge, that means your entire traffic will pass through the root bridge itself. So one switch will get so much of load. CPU usage will be high. Okay. So first of all, the time was so much, 50 seconds. So in the first improvement, your time was reduced. Okay. And the time was reduced in the second protocol, which is rapid spanning tree. Which is also known as RSTP. And the IEEE code for this 802.1W. This is D. This is here the time was only few seconds. The time was highly reduced and it became only few seconds. But again, this problem still remains only one STP for all VLANs. So they came up with a solution to this and they brought up MSTP, multiple spanning, which is MSTP. And the IEEE code for this .1H. Okay. So here the time was only very few seconds and one STP for a group of VLAN. Okay. That means what? That if you have 100 VLANs, for VLAN 1 to 10, one route bridge, 11 to 20, another route bridge, 21 to 30, another route bridge. This way your traffic will be diverted. Okay. And also your all ports, they will not remain in the blocking state. That means you can use the links. Okay. This is in the open standard. Now Cisco always wanted their own protocols. So let's talk about Cisco proprietary. So Cisco designed its first protocol, same like STP. Okay. They named it per VLAN spanning tree. They named it per VLAN spanning tree plus. That means PVST. So this protocol was similar to STP. It was taking 50 seconds. But Cisco made one improvement that they started already working on per VLAN system. That means one STP for each VLAN, one route bridge for each VLAN. Okay. So you can say one STP per VLAN. Then open standard came up with RSTP. So Cisco said, okay, we will also make improvements now. They said rapid PVST, rapid per VLAN spanning. Okay, which is RPVST. And in this, they reduce the time 2 seconds. And it was having one STP for per VLAN. Because Cisco was already working on per VLAN system. Then after Cisco didn't need MSTP. Why? Because if the protocol is already there, why to develop their own protocol with the same set of tasks? Okay. So even in Cisco, we sometimes use MSTP. In the organizations, we use MSTP because using one route bridge per VLAN becomes a lot of tasks. So you group VLANs, you make one route bridge. Okay. And by default in your Cisco switches, this is enabled. The IEEE means this protocol. Okay. I don't know why it shows IEEE, but actually this protocol is here. Okay. And when you want, you can go and enable RPVST. This is clear. So these are your STP protocol. Any doubt in this part? So this was your spanning tree protocol. If you have any doubt, you can ask. No? Then let's move on to the next part. Now here, employees were trying to be smart. Now we will try to be smart as a network admin. So we will go with another protocol, which is not protocol, but as method is known as Etherchannel. Sometimes also known as port channel. Etherchannel or port channel. Now, what is this Etherchannel or port channel concept? So imagine I have two switches. Okay. Now, normally what I'll do, I'll connect one link here. And now this is my fast Ethernet link. So if it is fast Ethernet link, that means what will be the bandwidth I'll be getting here? Fast Ethernet means 100 Mbps. Gigabit Ethernet means 1 Gbps. Okay. So right now here it is fast Ethernet. So that means the bandwidth that I'll be getting here is 100 Mbps. But I want more speed. I want more bandwidth. So what I'll do? Either I will go with new switches, but my company cannot afford them. My company cannot afford to have expense on switches. Gigabit switches I cannot go with. Okay. So what I can do, I can try to increase bandwidth. So if I'm connecting one link, I'm getting how much? 100. If I'll connect two links, it should be 200, right? But what will happen? See here. If there is a broadcast here, this side broadcast will come here, and this side broadcast will come here. Do you see what will happen? Loops will get created. And if loop will get created, my STP will already work. And if my STP will work, what will happen? One of the link will be blocked. So same thing you can see here. This link got blocked, right? The link got blocked here. You can see. I think it can change it somehow. I think it is visible. Okay, so here you can see that this link is blocked. So if this link is blocked, that means I cannot transfer data from here. This is in the blocking state. If no data transfer, whatever I spent on this cable is waste, right? So what is the use of this then? Why STP is blocking? Because according to STP, these two are different links, two separate links. According to STP, these are two separate links. So they will have root bridge election, all those elections, and they will see that, okay, this is the port. We cannot allow this port. We will block one link because there is a possibility of loop. Okay. So what we'll do, we'll combine these two ports into one. That these two ports, they will start behaving like one port. And if these ports, they will start behaving like one port. So according to STP, only one port, will combine them. These two ports we will combine, and these two ports also we will combine. So if we will combine the ports, they will start acting like one port, and one port means no loop. That means STP will not block it. And if STP will not block it, now I have two links that are working. I have my double bandwidth. Clear? So the process of combining multiple physical ports into a single logical port, that is your ether channel. Okay, this is ether channel with the help of which we are going to achieve this thing. Okay. So about ether channel, you can say it is used to combine multiple physical ports into a single logical port. Okay. Now for configuring ether channel, we have two protocols and one manual method. Total three methods are there. Number one is your LACP. Of course. Number one is PGP. Number two, LACP, and number three, static. These are the three ways. PAGP stands for Port Aggregation Protocol, and this is a Cisco proprietary. Okay. In this protocol, you can combine maximum of 8 links. That means you can have your bandwidth 8 times, right? And here, the modes that you have active and desirable mode.
So this is like one link.
Okay. The 8 links will act as a single link. Then we have LACP, which stands for Link Aggregation Control Protocol. This is open standard. And with the help of LACP, you can combine maximum of 16 links. Okay. So out of 16, your 8 links will be active and 8 will be standby. Okay, so if one of the active link goes down, automatically one standby link will come up and still you will have 8 links working. Okay, but in case of PAGP, if one link goes down, you have only 7 links. Okay, now here the modes that you have is active and passive. Okay. And static, this is a manual method to configure. Okay. And here we can combine maximum 8 links. Maximum of 8 links. And here on we have only one mode, which is on. Okay. Now in case of PGP, see, we are going to have 2 switches, right, which will be configuring the ether channel on 2 sides. So if one switch is auto, second switch is also auto, same like DTP, no ether channel. Okay. One is auto, second is desirable. Then we will have ether channel. And both are desirable, definitely ether channel. Then you will have. Okay. Here in this case, if one switch is auto, if one switch is active, another one is active. So active means ether channel. One is active, another one is passive. Ether channel. And both are passive? No ether channel. And in this case, we have only one possibility. Both have to be in the on mode. That means ether channel. So now one. Guys, wait a moment. Yes. Port and same. One is open standard, one is Cisco protocol. Always, Cisco will have their own protocol. Yes. Name. If they keep the same name, then there is no meaning. Right? Same thing. That's why they have kept the mode also like this. Okay. So now let's go and configure these things. So this is one, and let me create the lab so that in one lab we will see everything. So this side one, and this side one. Okay. And everywhere you will see that one link will be locked. You can see here this link and here this link. Now what? This side we will configure one protocol. This side one protocol. This side another protocol. And this side another protocol. Okay. This side, let's say I'll configure PGP. So in PGP, I will use the mode. This side desirable. This side auto. Here I'll use active and passive. Or I can use active, that is also fine. Okay, and protocol will be LACP. Mode is on. Mode is on. This is what static. Okay. Now let's go and configure it. See, configuration of Etherchannel is very easy. Single command is there. Okay. So how do you configure it? Use the same interface, range, and how many interfaces you want to select. So here you'll give a range of interfaces. Okay. Then after you will give the command channel group. Okay. Then here you'll give the group number. Like generally you will create 6 groups, up to 6 groups you can create. So channel group number, you will say mode. And now depending on what you are giving here, if you are giving here auto or desirable, it will automatically select PGP protocol. If you say active or passive, it will be LACP protocol. If you say on, it will become your static method. Okay. This is how you will configure. So let's go and configure. Here interface is 1 and 2. So I'll go to CLI. Interface range F0 by 1 and 2. Channel group 1. Okay, you can see up till 6 groups I can create here. Okay. So I'll say channel group 1 mode, and this side I'm setting up desirable mode. Done. Here I'll go. Here also port number 1 and 2. We go configuration coming out, interface range F0 by 1 and 2. Channel group 1 mode awesome. One side auto, one side desirable. Now you'll see all these ports, they will go green. Right? Now if I go and see here, show the channel summary. So you can see which protocol I'm using. PAGP. My name of interface is what? Port channel 1. And the code is S and U. S means it is layer 2 and U means it is in use. Okay, and these are the ports that are there in the port channel F0 by 1 and 2. This is clear. And if you want to see how many interfaces, you can say show Etherchannel. So it will give you more details, like you can combine maximum 8 ports. Right now you are using 2 ports. Like that also it will give you information. Clear? Right? Now let's go and configure in the same way LACP also. So here I'll go and configure. So here port number 1 and 2. And here it will be 3 and 4. Here group number 1, here group number 2, because 1 is already used. Okay. So go to this switch. CLI. Interface range F0 by 1 and 2. Channel group 1 mode passive. Okay, here I'm using passive. Here I'll use active. So here port number will be 3 and 4. Okay. Interface range F0 by 3 and 4. Channel group 2 mode active. Done. Yes, manually. Then only you will decide the protocol, right? And you can. Yes, active, same thing. So if I go on the switch tree and check to show Etherchannel summary. Protocol is LACP. Same thing for channel 1, S and U, layer 2 and up, and these are the ports in the Etherchannel. And then you can say do show Etherchannel, which will give you more details. Maximum of 16 ports you can combine. Right now, 2 ports are there. Yeah. Then on this switch, 1 and 2 is there, port number 1 and 2, and mode will be on. Interface range F0 by 1 and 2. Channel group 1, mode on. Done. Now same thing I'll go and configure here also. But this time port number 5 and 6, group number 3. Because 1 here, 2 here already used. Interface range F0 by 5 and 6. Channel group 3, mode on. Done. Let's go and check. To show ether channel. So here it will not show you the protocol name because this is not a protocol. Okay. This is a manual method, no protocol. So there is no protocol name. Port channel 1, S and U, layer 2 and up, and these are the ports in the ether channel. And if you check here, to show ether channel, you can see maximum of 8 ports you can combine. Right now, 2 ports are. Okay. So here we configured one protocol. This one switch we configured all the protocols. So now let's check here. Show ether channel summary. You can see port channel 1, PAGP, port channel 2, LACP, and port channel 3 on the static. Okay. But here, if you will see now, there is a bug also. If I say show ether channel, LACP, static, PAGP. Group number 1 was, see here, group number 1, PAGP, but here it is LACP. Group number 2, LACP. Here it is this. So this is a bug in this command. Only in this command there is a bug when you configure all the protocol. Otherwise, this output is correct. This is clear. In the real switches, it will not be there in packet traceability. This is clear how you will configure. And also you can see, like, if I check one interface bandwidth, so I can say show interface F0 by 1. What is my bandwidth here? Okay, here you can see easier way, 100 MB per second, right? And after ether channel, my port became what? Port channel. So if I check show interface port channel 1, what is my bandwidth? So my bandwidth get increased. This is how it. Clear? So this is your ether channel concept. Any doubts? You can do it. Yes, you can do it in the same way. Same command, same way. Okay. So this is your ether channel and STP. Any doubt? No? That's it then.
We will be the last.
Yes, next week we'll complete the online people. Any doubt?
No.
No. All right.
No.
Where active and desirable? Auto. Okay. It will be auto and desirable, yes. It will be auto and desirable. Let me replace it. Okay, then I'll see you guys tomorrow. Have a good day.